Good day, everybody. How are you all? Today we are going to talk about confidence interval for population proportion. So a simple random sample of 200 electronic components was tested and 17 of them were found defective. Construct a 99% confidence interval for the proportion of the components that are defective. So we will do part A first. Okay. So sample size is 200. Out of which 17. So this is n is 200 is sample size. And x, which is the small number or number of successes. We are looking for defective parts. So success in this case is to find a defective part. X is equal to 17 is usually the small number. So my C level is 0.99. Okay, so we will use TI-84 calculator to calculate the 99% confidence interval for the population proportion of defective parts for the population proportion. Okay. So I'll create some space for myself by moving this a little bit up. Okay. So I have to use my TI-84 calculator. So what do I do? So on the calculator, okay. So we press the stat button. So in the calculator, first thing we'll do is press the stat button. This is A. Then highlight test on the top row by moving the cursor on top of the test. Okay. And then we will scroll down. You will not see it in the first screen. So you have to scroll down with the down arrow key to go to 1 prop Z int. So we are looking for 1 prop Z int. Okay. This is option number A in the calculator. Once we find it, prop is proportion, Z int means interval. So once we align the cursor with number A, we hit or A, which is 1 prop Z test, 1 prop Z interval, 1 prop Z interval, which is in the second screen. We align the cursor with and hit enter. Then it asks for X. So for X, I'm going to type the small number, okay, which is 17. My N is sample size, okay. So I type N is 200. And my C level is 0.99. This is N. And the C level is 0.99. Okay. And then I go down to calculate. Bring the cursor on calculate. Bring the cursor on top of calculate and hit enter. So the 99% confidence interval is 0.034, comma 0.136. So with 99% confidence, we can state that the actual population proportion will fall between 0.034 and 0.136. Okay, so that is the interpretation of the 99% confidence interval. So that takes care of part A. So then it says in part B, so do not quit, because we have all the parts to cover, and I'll summarize at the end how I did all the parts. Use the results from the sample of 200 in part B to estimate the sample size needed so that the 99% confidence interval will have a margin of error equal to 0.04. Okay. So first we have to create some space. So maybe I should reduce this a little bit and then move it a little bit up. Okay, so let me change the color. Let's see how red works out. Part B. Okay, says use the results from the sample of 200. So N was 200 and my number of successes or number of defects, since I'm in the business to find defective parts, X is a small number, is 17. Okay, so my P hat or sample proportion of defective parts P hat is equal to X over N, which is 17 over 200. And that is equal to 17 divided by 200 is 0.085. So that is the sample proportion 0.85 actually. So I'll take care of that and make it 5. Now I need to calculate the minimum sample size necessary from the sample proportion data so that I can calculate, get a 99% confidence interval, which will have a margin of error equal to 0.04. So let me move again a little bit. Okay, so I will draw a diagram because I need the critical values of Z for 99% confidence interval. Now, 99% confidence interval. So this is Z in the horizontal axis. This is the standard normal curve. Sometimes called the Z curve. So 99%, the center Z is equal to 0. 99% confidence interval means the area in the center, okay, is 0.99. Okay. So for 99% confidence interval, area under the standard normal curve. Normal curve in the center is equal to 0.99. So area in two tails will be the remaining area. We know the total area under the standard normal curve is 1, out of which area in the center is 0.99. So area in the two tails is 1.1 minus 0.99, which is 0.01. Now notice this is area in two tails. So if I move this a little bit up, area in each tail, since the standard normal curve is symmetric, area in each tail will be half of the total area, will be half of area in two tails, or 0.01 divided by 2, which is equal to 0.005. Okay, so this area over here, area is 0.005, and this area over here, this area is also 0.005. So if you add 0.005 plus 0.99 plus again 0.005, total area is 1. Now this boundary which separates the central region, where the most probably, where we can state with 99% confidence that the population proportion will fall, okay? That is in the center, from the area in the tail, where most probably the population proportion will not fall. So the central area is where it will fall. The area in the two tails is where the population proportion will not fall. Hence, this vertical, where the vertical line is drawn from the horizontal axis, is called a critical value of Z. And specifically on the left, it is called minus Z alpha by 2. On the right, it is positive Z alpha by 2. So you ask me, what is alpha? Alpha is level of significance, which is 1 minus confidence interval, which is 1 minus our confidence is level is 0.99. So alpha by itself is 0.01, and area in each tail is alpha by 2 is 0.01 divided by 2 is 0.005. We already established that. Now let me change the color of the ink to something that is more readable. So let's do this. Let's use this. Okay. So I will just again remember what to do. So we have to use the sample proportion data from part A. We have to use a 99% confidence interval. We are establishing a minimum sample size necessary so that the margin of error is, that's what I want to make sure, is 0.004. So let me move up. Yeah, margin of error is 0.04. So what is the formula for the minimum sample size? Okay. Before we do that, let's establish the critical value of alpha by 2. Critical value of minus Z alpha by 2. So critical value in the left tail, and it is called a critical value because it separates the least probable region on the left tail from the central region, which is the most probable region and whose area is 0.99. So critical value in the left tail is minus Z alpha by 2. Of course, it is negative because it's on the left of 0. Center is 0, mean is 0. And it is minus Z alpha by 2 because area in the left tail, as we already established, is alpha by 2. So minus Z because it is negative and area in the left tail is alpha by 2. Hence the notation is minus Z alpha by 2. How to find that Z alpha by 2 using our calculator is the question. So what I will do is I will move up a little bit more. Okay. So we will use the calculator. So the function that we will use, we will first press the second button, then the verse button in the third row, and then select number 3, which is in norm. So it asks for area, that's the area in the left tail, which is 0.005. Its mean is already set up as 0, which is a standard normal curve, and sigma is 1. And then I paste, bring the cursor on paste, and hit enter and enter. Okay, so second, so it's second, then verse, then number 3, area in the left tail is 0.005. Do not change the mean from 0 and the standard deviation from 1 because those are the properties of the standard normal curve. Mean of 0, standard deviation of 1. Paste, enter, and enter. So minus Z alpha by 2 is minus 2.576. By symmetry, because it is located the same distance away from the center, Z alpha by 2 is 2.57676. 2.576. Okay, so let's erase that and write it properly. 2.576. So what are these? These are the critical value. This is a critical value, and on the right side, same critical value without the negative sign is same critical value. Okay. Now we have to utilize this. So what is the formula for the minimum sample size? So I have to create some space. Okay. And I have to move it a little bit up. Okay, go back here. That should do it. Okay. Okay. So the formula for minimum sample size, minimum sample size, sample size. Nah, that doesn't look all that hot, so I'll use a different pen. Minimum sample size formula is N equal to P hat, that means sample proportion, times 1 minus P hat multiplied by Z alpha by 2 divided by M. And the whole thing is squared. So P hat is the sample proportion. In this problem, it is 0.085, which I calculated before. My Z alpha by 2 is 2.576. And if I move up a little bit, the margin of error, M, margin of error, and whoops, take care of the margin. Okay. So I'll make it a little bigger. Maybe a little that smaller. Yeah. So M is the margin of error. M is the margin of error. And margin of error means difference between sample proportion and the population proportion. So this is sample proportion, which we have calculated, proportion, and this is population proportion. So again, let me erase this unnecessary line. Sample proportion, and this is population proportion, Okay. So the margin of error has been given to us. It is, I believe, 0.04. So we know everything in this formula. So let's do the calculation. Create some space and do the calculation. Okay. So N is the minimum sample size, is P hat, which is 0.085. Then we put the left parenthesis 1 minus 0.085. And then inside the parenthesis Z alpha by 2, which is 2.576. And then the margin of error, which has been given to us, is 0.04. And let's make sure the margin of yes. And then we put the parenthesis and we have to square it. The way we square it in the calculator is to press the X square button in the first column of keys on the left. That puts the exponent 2 here and we hit enter. Remember, sample size, we always round it up. So here we go, 0.085, left parenthesis, 1 minus 0.085, right parenthesis, then again left parenthesis, 2.576. That will be divided by margin of error, which is 0.04. Then right parenthesis, and do not forget to press the X square button in the first column of keys, which puts the exponent 2 outside the last parenthesis, and hit enter. And the answer is not 322.56. The answer is minimum sample size is 323. That's your answer for part B, 323. Okay, I will summarize everything at the end. Now let's focus on part C. So let's read the part C again. So I'll scroll up to read the part C, which says a simple random sample of a different type of component will be tested. At this point, there is no estimate of the population of the proportion defective. Find the sample size so that a 99% confidence will have a margin of error no greater than 0.04. So bottom line in part C, we do not know the sample proportion P hat to be used in the formula. So what do we do? So let's move it a little bit farther up. Okay. So part C, no estimate of P hat is available. Use, and this comes directly from the textbook, use P hat equal to 0.5 in that case. Okay. So N is equal to, instead of P hat 0.085, we will write 0.5 times 1 minus 0.5 for 1 minus P hat, and then multiplied by critical value of Z, which is 2.576. Whole thing is divided by margin of error. the maximum is 0.04. Then we press the X square button, which is in the first column halfway down. This puts the exponent 2, and then we enter. So let's do the calculation. So 0.5, then left parenthesis 1 minus 0.5, right parenthesis, then left parenthesis 2.576 divided by 0.04, right parenthesis, and then X square it and hit enter, round it up, it is 1037. So minimum sample size necessary is N, after rounding it up, is 1037. N is 1037. Okay, so that there is no doubt in anybody's mind, this is a 1. So it is 1037 is the minimum sample size, is the minimum sample size. Sample size when p hat is not available. So let's summarize before we end. Okay, so let's go to the top first. Read the problem. A simple random sample of 200 electronic components were tested and 17 of them were found defective. Construct a 99% confidence interval for the proportion of the components that are defective. So here the sample size n is 200. The number of successes in this case, our job is to find defectives. So success is actually a number of defectives is 17. So C level is 0.99. And we use TI-84 to calculate the 99% confidence interval for the population proportion of defective components. And we use stat test, and we scroll down to one prop Z int, which is number A in the second screen. Enter the value of X, enter the value of N, select proper C level, and calculate, and we get the 99% confidence interval as between 0.034 and 0.136. What do these two numbers mean? With 99% confidence, we can state that the actual population proportion will fall between 0.034 and 0.136. Now, in part B, we have been asked, use the results from the sample of 200 to estimate the sample size needed so that the 99% confidence interval will have a margin of error equal to 0.04. Okay, so we need the sample size, minimum sample size necessary. And we can use the sample proportion from the part A. But before we calculate the minimum sample size, we need the critical value of Z on the two tails. In a confidence interval of 0.99, the area in the center of the standard normal curve is 0.99, and area in the two tails is 1 minus 0.99, which is 0.01. So area in each tail, because of symmetry, is 0.01 divided by 2, which is 0.005. Now we need to find the critical value of Z. How do I do that? I use my calculator, press second, then verse, and then number 3, which is in norm, and plug the area or enter the area of 0.005 in the left tail. Mean is 0, standard normal curve, sigma is 1, best, and minus Z alpha by 2 is minus 2.576. By symmetry, the critical value of Z with the same area in the right tail of 0.005 is 2.576. So the formula for minimum sample size is given here. It's n equal to p hat times 1 minus p hat in times, in parentheses, Z alpha by 2 divided by m, and the whole thing is squared. Now, p hat is sample proportion is 0.085. M is the margin of error. What is margin of error? It's sample proportion minus population proportion. And that has been given to us as 0.04. So we plug the values in the calculator or in the equation, in the expression. N is 0.085, which is sample proportion times 1 minus the sample proportion of 0.085. Then we press the right parenthesis and then again left parenthesis. Inside the left parenthesis, now the critical value of z, which is 2.576, and that has to be divided by 0.04. Close the right parenthesis and do not forget to press the x square button to get the exponent 2 on the last parenthesis. And we round it up, n is 323. Part C, we are going to use the same formula, but the only twist here, we do not know p hat. When p hat is not known, the textbook, all textbooks suggest use p hat is equal to 0.5 because this is gives you a conservative estimate of the sample size. So instead of p hat, we are going to use p hat as 0.5, not 0.085 from the last problem. So n is 0.5 for p hat times 1 minus 0.5, and inside the parenthesis, the terms remain the same as before. We do the calculation, and after rounding up, the minimum sample size is 1037. Why this is a conservative estimate? You can show, or one can show, that if I use any other value of p hat, either greater than 0.5 or less than 0.5, I will get a sample size which is smaller than what I get with 0.5. Hence, 0.5 is considered as a conservative estimate for p hat because that gives us the maximum sample size. So I will stop here today. So this was a problem on confidence interval calculation for population proportion, as well as a calculation for minimum sample size. If you have any question or comment, write me a note. I'll get back to you as soon as possible. If you like this video, please give me a thumbs up. I really appreciate that. Give me a strong thumbs up. Okay? And if you like this video, share with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button at the bottom right corner. And do not miss me next time when I will come back with another problem, interesting solution. I have solved lots of problems in my channel, Math Science Topia, where you can access these problems, download these, and you can become the best in maths. Thanks for watching. Take care, and do not miss me next time. Take care. Have a nice day. See you.